Okay, Algebra 2 students, this is a video for example 3 for section 2.7. We're going to apply the linear quadratic system.
Andrew kicks a ball up a hill for his dog Laika to chase. The hill is modeled by a line through the origin. The path of the ball is modeled by the quadratic function shown. How far does the ball travel horizontally? How far must Laika run up the hill to catch it?
Okay, we have the two equations, a quadratic and a linear one. We're going to see if we can find that intersection point. Okay, since they're both set equal to y, we can set the two expressions equal to each other and have the 0.5x equals a negative 0.5x squared plus 6x. And then we're going to subtract 0.5x to both sides because we want to set it equal to 0. Once we set it equal to 0, we can take this and use the quadratic equation if you want. They have done what I would have done. I noticed that there's only two terms. They both have x in it, so I can factor an x out. And we have 0.5 and 5.5, so I can factor out a negative 0.5. When you take a negative 0.5 x out of this, you're left with x. And if you divide 5.5 by negative 0.5, you get negative 11. And now that it's factored into these two, you can set them each equal to 0. The negative 0.5x equal to 0, you divide both sides by negative 0.5 and get x equals 0. So there's one of the x values. The other way that this expression could equal 0 is if x minus 11 equals 0. And if that's true, we would add 11 to both sides and get x equal 11. So let's look at the graph again, or the diagram. At 0, the dog and the ball are at the same spot, and up here at a value of 11 for x, they're at the same spot. Let's find what the y value is for that. We would plug the 11 into one of the equations. I think plugging into this one would be the easiest. Plug 11 into that and you get 5.5. So 11 feet over and 5 feet up. But they also asked how far up the hill does the dog go? And we can use the Pythagorean theorem or the distance formula, since we know the horizontal distance was 11 and the vertical distance was 5.5. We can go 11 squared plus 5.5 squared will equal the hypotenuse squared. Take the square root of both sides and get about 12.3 feet. So that's about how far the dog needs to go up the hill, 12.3 feet. Moving on to the one for you to try. We have revenue for a high school band concerts given by this complex formula where x is the ticket price in dollars. The cost of the concert is given by the function y equals 490 minus 30x, where x is still the ticket price. At what ticket price will the band make enough revenue to cover the cost? Now, I don't think this is realistic because this value of x, if I plug in a 10 for $10 for a ticket price, 490 minus 300. If I plug in a 20, I don't think, like, how can they, I don't understand how the cost of the concert is directly related to the ticket price. I think it would be more like the number of tickets, but let's still go with it. Y equals negative 30x squared plus 250x would be a parabola that opens down because of the negative 30. And because they're asking what ticket price will the band make enough revenue to cover the cost, I assume this linear equation, which has negative 30 for a slope, somehow cuts through. But the good news is, you don't have to understand all that. You just have to apply what we've already learned recently about how to find the intersection between a linear and a quadratic function. I'd start off by setting them equal to each other because they both equal y. So I can just set these both equal to each other. This will take some time. 490, and I've run out of space. 490 minus 30x. All right, I want to set this equal to 0. Let's see, which way should I go? I guess I'm going to move these two numbers on the right to the left. So I'm going to add 30x to this, and I'm going to subtract 490. And I guess there wasn't any x squared, so I still have negative 30x squared. And what was I going to do? Add 30x, so I get plus 250x. I mean, plus 280x. And I want to subtract 490 to both sides. And that's going to equal 0. Well, they're all divisible by 10, so I could make this a 3, and this a 28, and this a 49. And since it's 49, the only way to get 49 is to go 7 times 7. I think I might factor it. Fill in these other parts that I didn't. You could use the quadratic right off. I'll show you even a faster way at the end. I'm not sure if it's allowed or not, but okay, I'm going to factor it because I noticed 49 can only be 7 times 7. One's got to be positive, one's got to be negative. I also have negative 3x squared, so one of these has to have a negative 3x. And one has x. You can use the quadratic. I'm just solving by factoring because I notice 49, 7 times 7. I need to get positive 28 in the center here. I already have a negative 3x, so I probably need to make that positive. So I'm going to make this the minus and this the positive. How did I decide on that? Because I wanted positive 28, so negative 3 times negative 7 is positive 21, plus 7 gives me the 28. Now that I have these two, I know one of the intersection points is when x minus 7 equals 0, so that's 7. And the other point is going to be subtract 7 from both sides, and then divide by 3, so 7 thirds. Okay, let me show you a faster way to get those numbers. The faster way, because they didn't say what method we had to use, I'm just going to use my graphing calculator and type in negative 30x squared plus 250x. And in, 250x. And in my other equation, I'll have 490 minus 30x. But when you go to graph it, like let's say I say zoom standard, not much shows up. Because you think about these numbers and how big they are. If x is 0, y is going to be almost 500. So let me go into the window and change the window. What would work for an x value? Well, we already know they cross at, oh, we don't know. I'm pretending we don't know that they cross at 7. Darn it. Well, let's see. What would be realistic? How big of an x do we need for this to come out to 0? Like, if I plugged in 20, 20 times 30 is 600. That's way more than. So I'm going to go from 0, because this can't have a negative ticket value. I'm going to go up to 20. The x scale that I'm going to use, oh, I didn't click the 2. 20. I want to tick mark every 5, I guess. Otherwise, it looks kind of crowded. And the y values, I already said it goes up to almost 500. So I'm going to go from 0 up to 500. And the scale, this time I'm going to go every 100. All right, now let's see what the graph looks like. There's the parabola. There's the line cutting through. To get those numbers, the 7 thirds and the 7, you can do calc intersect, right? If you forgot that, why not? I know the video's going long, but it's worth it. First curve, I only have 2 curves, so that's the first curve, sure. That's the second curve, sure. What's the closest point? Let's find the 7 thirds. I'm I'm going to go all the way up to the 7/3. All right, that's definitely closer to that root. So let's find, there it is, 2.333. That's 7/3. Okay, and then you would just calc intersect to find the other one. That would have been better than having to do it by hand, right? Let's me make sure that, oh, at what ticket price will the band make enough revenue to cover the cost? I didn't really, the cost of the concert is this line. We need this, and then there's the revenue. This is how much money they make. So we want to be in this range, right? So we want to be between these two numbers. So that's what I'm looking for in their answer, to be between 2.33 and 7. I forgot to even answer the question. Good thing I did it before I clicked check answer. 230 or 233 and $7. It needs to be between that in order for them to make money. All right, your teacher should be able to assign to you some of these problems. 18, 24, 26, and 29. That's it for this video. Have a great day.